Hello and welcome to the AI with Arun show. In this episode, we are going to talk about NVIDIA's groundbreaking platform, Cosmos, which is designed to be the architectural blueprint for the future. We'll explore how NVIDIA is building the very foundation of the next generation of intelligent machines. The vision for physical AI comes from the very top. NVIDIA's leadership sees this as the next great technological leap. But what is it exactly? Physical AI is the convergence of two massive fields, artificial intelligence on the one side and robotics on the other, supercharged by the power of computer graphics. Think of humanoid robots in our factories and warehouses, autonomous vehicles navigating our cities, or smart infrastructure that anticipate our needs. NVIDIA believes that this is not just an evolution, it's a multi-trillion dollar industrial revolution in the making. So if this future is so close, what is holding us back? It boils down to two fundamental problems that have plagued robotics for decades. First, the data bottleneck. Training a robot requires massive amounts of data. To learn how to pick up a cup, the robot needs to see it from every angle, in every lighting conditions, and in thousands of different environments. Collecting this data in the real world is incredibly expensive, time consuming, and often dangerous. The second problem is the sim to real gap. The obvious solution to the data problem is to use simulation. Now let's just create virtual worlds to train our robots. The problem is reality is messy. When a robot trained in a perfect, clean simulation tries to operate in our unpredictable world, its performance plummets. That gap between simulation and reality has been a massive barrier until now. The proposed solution to these problems is a new paradigm called the World Foundation Model. Now imagine an AI that has been trained on such vast and diverse data that it has learned the underlying physics, our relationships of our world. It's like a digital twin of the world. This is the core idea behind NVIDIA Cosmos. It is a generative model that can create and manipulate realistic, physically plausible data. By doing this, it directly attacks both of our core challenges. It solves the data bottleneck by generating limitless synthetic data, and it helps close the simulation to real gap by making the data far more realistic and diverse than ever before. So how does it work? It's important to know that Cosmos is not one single giant AI. It's a comprehensive platform made of three specialized foundation models that work together. First, there is Cosmos Predict. This model generates future possibilities. You can give it a picture or a line of text, and it will create a video showing what might happen next. Then there is Cosmos Transfer. This is the bridge from simulation to reality. It takes a basic simulated video and transforms it, adding photorealistic textures, different lighting, and even changing the weather to create countless variations. And finally, Cosmos Reason. This is the brain of the operation. It's a vision language model with 7 billion parameters that provides common sense and physical reasoning, helping a robot understand why things happen and what it should do next. Having powerful models is one thing, but making them safe and easy to use is another. NVIDIA has built an entire infrastructure around the core models. Cosmos Curator is an AI data assistant. It automatically sifts through mountains of sensor data, filtering, annotating, and organizing it for training. Then Cosmos Guardrails are crucial for safety. They act as a filter, blocking harmful requests and ensuring the AI does not generate unsafe or inappropriate content, which is critical for training robots for the real world. And Cosmos Prompt Unsampler, I'm sorry, Cosmos Prompt Upsampler, not Unsampler, but Upsampler. It's a creative partner. A developer can write a simple prompt like a robot picks up a box, and the upsampler will automatically add rich detail to generate a much higher quality and more specific video from the AI. Let's dive a little deeper into Cosmos Transfer because it's a real game changer. Its power lies in its controllability. It uses a novel design with multiple control branches. Think of these as different knobs a researcher or developer can turn. One branch controls depth, another controls the edges of objects, another the layout of the scene. This gives developers precise controls to specify exactly how the simulated data should be transformed into photorealistic video. This architecture is also highly efficient, allowing new controls to be added without retraining the entire model from scratch. Now, let's look at Cosmos Reason, the model that provides common sense. Its key differentiator is something called the chain of thought reasoning. Instead of just giving a direct answer, it generates a step by step logical process. If you ask it, is the robot's action safe? It won't just say yes or a no. It might respond, the robot is picking up a knife. The blade is pointing down. There are no people nearby. Therefore, the action is currently safe. This ability to handle ambiguity and apply common sense is what will allow the robots to make complex, nuanced decisions in the real world. Now, as we have said, Cosmos does not exist in a vacuum. It is the connective tissue in NVIDIA's end to end platform for robotics. It starts with NVIDIA Omniverse, a platform for creating physically accurate 3D virtual worlds. Those worlds are used in Isaac Sim, a dedicated application for simulating robots. Isaac Sim generates the initial data, like a robot moving in a virtual factory. That data is then fed to Cosmos for transformation and augmentation. Finally, the newly generated massive dataset is used in Isaac Lab, an open source framework where thousands of robot instances can be trained in parallel before being deployed to the world. This entire ecosystem comes together in something called NVIDIA Project Root, which stands for General Robot Zero Zero Technology. This is where we see the synthetic data flywheel in action. It works in two ways. The Groot mimic can take a few examples of a human performing a task and then use Cosmos Transfer to generate a massive dataset of a robot performing that same task, but with thousands of variations in the environment. Groot Dreams goes a step further. It can dream up entirely new motions and tasks from just a single image or text prompt, using Cosmos Predict and Reason to generate completely synthetic training data. The impact is staggering. NVIDIA research used this process to generate training data in just 36 hours, a task that would have taken nearly 3 months using traditional methods. So, what are the real world applications? This is not just a research project, it's already being used by industry leaders. In humanoid robots, companies like Boston Dynamics, Agility Robotics, and Figure AI are using Cosmos to generate data for complex tasks like walking and manipulation. In autonomous vehicles, Uber is using Cosmos Reason to help analyze complex driving scenarios, and Magna is using it for last mile delivery robots. And in smart infrastructure, companies are using Cosmos to monitor traffic, improve city planning, and detect safety violations in industrial settings. Now, it's important to be realistic. This technology is powerful, but it's not perfect. There are limitations that we need to acknowledge. First, it lacks determinism. Because Cosmos is a generative model, it's inherently unpredictable, which makes it unsuitable for the kind of rigorous, repeatable testing needed for final validation. There is also uncertain physical fidelity. The AI is incredibly good, but it can still generate scenarios that subtly violate laws of physics, which could teach robots the wrong lessons. Finally, there are technical constraints. The video outputs are still relatively low resolution, and it does not yet support all the sensor types a real robot would have. This is why Cosmos is positioned for training, where massive scale is needed, rather than for final validation, which still requires real world testing. Now, let's look at some competing philosophies. So, NVIDIA's approach is not the only one. It's useful to compare it with another major player, Tesla. NVIDIA has a simulation first approach. It's a horizontal strategy designed to provide tools for the entire industry. It's compute centric and it solves the cold start problem for companies that don't have millions of robots already in the field. Tesla has a data first approach. Its vertically integrated strategy that leverages its fleet of millions of vehicles as a planetary scale data collection network. It prioritizes real world data above all else. Both have their own challenges. Nvidia has to constantly work to bridge the sim to real gap, while Tesla's challenge is transferring its knowledge from driving to more complex manipulation tasks. Looking ahead, Nvidia is already planning the next version with simpler controls and faster generation. They envision a multiverse capability where AI can simulate and evaluate all possible outcomes of an action. But with this power comes great responsibility. We have to address the profound ethical challenge, the risk of bias amplification, where biases in a small dataset get magnified across trillions of synthetic data points. The question of accountability, where an accident is caused by a robot trained on a complex pipeline of generated data, and the safety concerns that arise from over relying on simulation that is not a perfect mirror of reality. These are the hard questions that the entire industry must address thoughtfully as we move forward. In conclusion, NVIDIA Cosmos represents a truly transformative platform. It is designed to solve the single most fundamental constraints in robotics, the scarcity of good data. Through its tightly integrated ecosystem, Cosmos creates a synthetic data flywheel that promises to dramatically accelerate the development of physical AI. While it's best suited for training rather than final validation today, Cosmos is undeniably a foundational pillar for what will become the next industrial revolution. It's not just a tool, it's a launchpad. This brings us to the final crucial point about NVIDIA's strategy. With this platform, NVIDIA has positioned itself as something more than just a hardware supplier. They are becoming the indispensable infrastructure provider for the entire physical AI industry. They are engineering a future where the most valuable commodity is no longer a proprietary data set, which only a few companies have, but computational power, which is what NVIDIA delivers. With that, we come to the end of the show. Thank you for watching. Like, share, subscribe, and support our work by joining us as a member.